Welcome to 3GPP 5G RF Features Explained series, where we break down the complex world of 5G radio design into simple, practical insights. If you work with RF testing or network optimization, this series is for you. Today, we'll start with the foundation. What exactly are 5G RF features, and why are they so important? When 3GPP defines RF features, it refers to everything related to radio frequency performance and capability of both base stations and user equipment. It's what determines how strong, clean, and reliable the transmitted and received signals are. These include power, sensitivity, spurious emissions, frequency bands, and even features like beamforming or carrier aggregation. RF features differ from RF requirements. Requirements are the limits set by 3GPP RAN 4, while features are how the design meets or extends these limits. In LTE, RF features were relatively static: fixed carrier bandwidth, limited antenna arrays, and predictable duplex modes. 5G new radio changed that dramatically. Now, we have flexible numerologies, scalable bandwidths up to 400 MHz, and beam-based operation. This flexibility makes new radio powerful, but also pushes RF designers and testers to new limits. Behind every RF specification stands 3GPP RAN 4, the working group responsible for defining and verifying RF requirements for new radio and LTE. They produce the technical specifications like TS38.101, which is for UERF requirements, TS38.104, which defines the base station RF requirements, and then TS38.141, this defines the test procedures. These documents defines how transmitter, receivers, and an over-the-air performance must behave, ensuring devices from different vendors work seamlessly worldwide. Their other groups include RAN 5, which are not so closely related to our topic. We don't discuss these groups here. And you can find the 3GPP specification from this link. I'll paste the link in the description. You will often hear FR1 and then FR2. FR1 covers sub-6 GHz, typically from 410 MHz to 7.125 GHz. FR2 includes millimeter wave frequencies from 24.25 GHz to 71 GHz. Each range has unique challenges. FR1 provides broader coverage but a limited bandwidth. FR2, massive bandwidth but higher path loss, needing beamforming and precise calibration. All these RF features directly affect user experience. High EVM or poor spurious separation means dropped throughput. Weak beam tracking means unstable links. Understanding RF features helps engineers ensure the radio link remains clean, efficient, and interoperable across devices and vendors. In later episodes, we'll dive deeper from frequency band and carrier aggregation to beamforming, power, and EVM testing, with clear visuals and practical examples. That's it for episode 1, the foundation of 5G RF features. In the next episode, we will explore 5G frequency bands and channel bandwidths, and how new radio achieves flexibility across FR1 and FR2. Don't forget to subscribe for more RF tips and insights. Thank you.